Yeah, formality. It's yeah, I won't finish that.
I know you, Anna. You see, you see, you go space, you. You try 1 month and you see some kind of. Ah, it's a baby name who I'm trying. It's him. It's him.
All right. Good morning to you all.
That's you. I just got
Good
let me
morning.
see.
Good morning to you all.
I'm sorry.
Yes. Please, those having extra meetings at the background should mute themselves, please.
Mute themselves, please.
I think the noise is coming from Mr.
I
Godfred.
think the noise is coming from Mr. Godfred.
Okay. Thank you very much. Yes. And then good morning once again. I would want to officially welcome you to this semester and this course. Please, if you can hear me, just give me a thumbs up with an emoji. If you can hear me, just give me a thumbs up with an emoji. All right, thank you. And I hope you can see my slides too. Just a thumbs up. If you can see my slide, just a thumbs up. All right, thank you. Thank you. So means we are set. All right, so thank you very much for being on this call and in this class. This is Nature of Science, ESC 206D, if I got it right. No, 201D, Nature of Science. And then my name is Stephen Addison, and I'm going to be your course tutor for this particular course. As you are aware, this is more like a classroom. We are in the global world and things are changing. So regardless of the mood that you find yourself, it is still a classroom. And it is important that we observe every rules that we would have to observe in a classroom settings, because it's a classroom. This is going to be a very interactive course. Yes, it's going to be a very interactive course. At this rate, level 200, I'm sure, and I presume that we are all science tutors. So I'm not just going to be the one talking. Everyone is going to share his or her idea. If you have anything to say in the course of the presentation or the discussion, you just use the emoji hand there, you click on it, and if I see your hand, I'll call you, and then you share with us anything that you would want to share with me or the class. And that is it. We are all learning from each other, so please feel free. As I said earlier, it's going to be very interactive, so feel free to share whatever you want to share with as we go along. Everything that is on the slide is directly taken from the course manual, of which I know it's been shared with you. So there isn't going to be any need for me sharing my slide with you. Yes, because everything was just taken directly from the course model or the handout. We just slightly additions to it. So I don't think it's going to be an issue with that. So that is it. As I said, my name is Stephen Addison, and I'm going to be your course tutor. So if there's anything I need to know about the class, you kindly let me know. Is there a course rep here? Is there a course rep here? I don't know. Is there a course rep around? If there's a course rep, let me see by hand if there's a course rep. Please, is there a course rep around?
Sir, we don't have one for now because this is a new course we are all doing.
Okay. And please, are you okay? Obviously, you are from different centers, right?
Yes, please.
Okay. So okay. So please, it will be very beneficial if each of probably all of the centers will elect one person as the course rep for this course for that particular center, and that person should contact me. I think my details are on the timetable, so that in case of any information, it will be sent to the person. Okay, so each center should gather and then get me what do you call it, a course rep. Okay, and that course rep should also give me a list of students who are doing this course in his or her center. Okay, it will be used for your presentation and also scoring. So please, each center, as I said, should elect one person as a course rep for this course for each center, and that person should contact me with a list of students who have registered for this course. We'll hopefully compare it with the one that the college has, and then we'll be using it for our groupings for our presentation. So please, let's take note of that. So hopefully by the close of this week, next week, I should be able to get the names of the individual course reps. All right. Okay. Yeah. Thank you very much. So let's zoom in right into it. As I said earlier, so as I said, I'm going to be the course tutor for this course, and we are looking at Nature of Science, ESC201D, and this is a 3 credit hour course. Though on the timetable it is 11:30 to 1, but it is a 3-hour course, and so per the university rules, we are supposed to decide on another day that we would have the extra 1 hour. Okay, per the university rules, we would have to decide on a day that we're going to have the extra 1 hour. So I would leave that with you to think about it, and then we'll decide at the end of this class. We'll need to have a separate day that will have the extra 1 hour to make up for the 3-hour course, 3 credit hours that we need to spend on this course. So we'll do that at the end of the class. And then per plan, we are supposed to complete Unit 1 this week. Yes, we are supposed to complete Unit 1 this week. And these are basically the objectives that we would have to achieve at the end of Unit 1. And as I said, everything is taken directly from the course model. So you can check it up and then make your necessary inference, and then we are done. So these are the objectives for Unit 1. We have to distinguish between science and science education, explain the aims of science education, explain the characteristics of scientific literacy, assess the status of scientific knowledge, and all those things that we would have to achieve. So we'll zoom in right into it and look at the session 1. As you know, each unit is divided into sessions. All right, each unit is divided into sessions. I think unit 1 has about 6 sessions. So we would have to cover all the 6 sessions here. And so we'll start right into it with section 1. And section 1, we are going to look at science and science education. We're going to look at science and science education. What is science and what is science education? I know there's always that confusion between the two. There's always that confusion between the two. And so we are going to look at that. All right. So, as I said, it's going to be interactive. So even before we zoom in, I would want to add, or pose this to the class. What is science? What is science? If you say science, what is it? And it's a question to all of us. What is science? We are science teachers at this stage, so please, what is science?
Because unless you mute your unmute it.
As I said,
Yes, just put your hand up and I'll call you, please. Okay, just put your hand up and I'll call you. You'll mute yourself when you speak. Mr. Abdul Rahman.
True observation and experimentation. Hey, mommy, come on.
Please mute yourself. Mr. Abdul. Kindly mute yourself. All right. So please, what is science? Just put up your hand and I'll call you, please. Okay, Mr. Eric Owusu Boating.
No.
Hello, sir.
All right, sir, Mr. Eric.
Science deals with the study of nature and how nature behaves. And normally
Science
it
deals with the
happens
study of
through
nature.
and how nature behaves.
All right.
And normally it deals with experimentation and through observation and other stuff that helps in bringing out facts.
Okay. Okay. Thank you. Please, any other? Okay, Mr. Osu James.
I think it's a matter of obtaining knowledge through observation and experimentation.
Okay. All right. So yes. Okay. Thank you, Mr. James. Any one more, then we continue. One more.
Okay.
Okay.
I think science is the study of nature through demonstration, application, and then experimentation.
Okay. Okay. All right. So thank you all for your response. So if you take a critical look at the responses that you gave, it all has to do with the study of nature. Some say it's the method of obtaining knowledge through observation and experimentation. When you analyze the responses that you gave very critically, you realize that there are a couple of keywords that comes into play. The study. And once there's studying, there's acquisition of knowledge. All right? Once there's studying, there's acquisition of knowledge. And how do we gain this knowledge? We gain this knowledge through certain practices. That is what distinguishes science from the other disciplines. Other disciplines but they have their own method through which they obtain this knowledge. But for science, we obtain knowledge through about what? About the nature, about our environment, about the world that we live in. And obtaining this knowledge is done through certain processes, certain standard processes, certain accepted processes. So in order for you to gain scientific knowledge, you have to go through these processes before you can gain that knowledge. And that is basically what science is all about. You understand? So in the model, it says science is a body of knowledge obtained through these processes. You have objectivity, logical observation, measurement, and systematic analysis of phenomena. All of this comes together into the experimentations that we do. So before someone conducts a scientific experiment or a scientific inquiry, there should be an investigation, there should be an observation, there should be an experimentation, there should be analysis of data, there should be a conclusion. And we learn this all through the scientific method that we have, or we learned in our elementary school. Those are the processes that we go through to obtain this knowledge. All right. So everything that you said is true. We obtain knowledge from science, and knowledge about what? Knowledge about environment, about things, all the things surrounding us. We obtain knowledge of them through science. And we obtain this knowledge through systematic processes. We obtain them through systematic processes. And that is what we are talking about. Okay. And one will ask, why do we even acquire the scientific knowledge that we do? Why do we acquire the scientific knowledge that we do? Mr. Is it Padaset? Please mute yourself. You are disrupting the class. Yes, please, you mute yourself.
Okay, so we are taking class tomorrow. 17. Are you all comfortable?
Okay, thank you. So one will ask, why do we even acquire this knowledge? What is important from the scientific knowledge that we acquire? Now, we acquire scientific knowledge in order to explain the happenings in our everyday life. All right, we acquire the knowledge to explain everything that happens in our lives. We acquire the knowledge to describe events. All right, to describe events, to diagnose of the nature of conditions. So what happens is that the scientific knowledge that we gain is not just writing exams and passing. It also helps us in the nitty-gritty things that we encounter in our daily lives. Some things that happens around us, we use this knowledge to explain it. All right. Some events that occurs, like the natural phenomena, rains, earthquakes, volcanoes, why the sun is even shining so bright, the seasons, how food even cooks, and all those things, we're able to explain through the scientific knowledge that we gain. And we're able to also diagnose conditions that occur in nature. All right. So that is what we use the scientific knowledge for, not just in the classrooms, not just writing exams and passing. All right. So science throws more light on what already exists in nature. So everything that we learn in science is not strange. They're already there. They are already there. Okay. All that we do is just to explain why these things happen or why these things occur. All right. So everything that science talks about already exists in nature. What we do is just to tell you why it is so and why it happens that way. You understand? So that is science for you. Now, we move on to science education. As I said earlier, it is always confusing. People always confuse science with science education. And today we are going to actually clear all doubts. All right. Now, science and science education is different. Science and science education is different. There are two different ways. As you stated earlier, science is a method of obtaining knowledge. Science is explaining things that happens around us. All right. Now, when we come to science education, we are just talking about a field that seeks to produce scientifically literate people. Now, it is concerned with how science is being taught. That is the general overview of science education. When we're talking about science education, we're looking at how science is being taught, the models that we need, the modalities, the curriculum. Okay, so that is basically what science education is. And when we look on the other hand, what science is, the method of obtaining knowledge. Science education, on the other hand, is just concerned with how we teach science in our classrooms. Okay, so it's concerned with how science is being taught, how it is being learned, the teaching methods that we use in teaching science, the strategies, the curriculum designs that we use in teaching science, the assessment methods. All these things encompasses what science education is. All right. So this is difference between science and science education. There are two different things. Whilst one is the knowledge that we gain, the other is how we can teach that knowledge that it is being gained. How we can teach it to others, how we can teach it to our children, we can teach it to our students. That is what science education is concerned. That is the bedrock upon which scientific and technological development depends. It is said that the development of every country depends strictly on its education. And it mostly also depends strictly on its science and technological educations. So how well we teach our sciences to our students, how well we teach our sciences to those around us, greatly impacts our economy. And so it is important that we look at how to teach science well. I have had my own experience as a student before, so I'm very particular about how we as teachers, I'm a teacher and you are also teachers, how we as teachers, we teach science. It is very, very important that we look at it. Done a couple of research and then a lot of suggestions goes through, and then the ordinary teacher doesn't even know how to implement all these suggestions. But we can also advise ourselves as teachers. Okay, the traditional way of teaching science needs to stop. It's not helping us. It's not helping our country well. So then there needs to be a change in that. And this is a step. Learning about the nature of science will help us know how best to teach science. All right. taking this course will help us how best to teach science. It's not just a course that you want to do and pass. I've heard a lot of students say, "Oh, the nature of science there, what at all do we need to know? It's all about reading." But I tell you that taking this course and taking it seriously, you get to appreciate what science is all about, what scientific knowledge is all about, and it will enable you to learn how to teach it well. All right. So that's basically what we're going to do today. Now, so that is science. That is science, and that is science education. So even before I move on, this is a general question. In your own way, how would you distinguish between science and science education? This is a question to all of us. In your own way, how would you distinguish between science and science education? It's to the whole class, please. All right, Madam Benis.
Thank you, sir. So actually, my name is Philemon.
All right, just Philemon.
Okay. With the science, I think how I can distinguish science from science education is science, as we said, is the acquisition of knowledge through observation and experimentation. And then with the knowledge acquired in science, as transferring the knowledge to have a positive impact in the lives of the society or the learners we are teaching has to do with the science education. So spreading the knowledge acquired in science in order to have an impact on the learners we are teaching and the society or the environment as a whole. Thank you.
All right, thank you too. Please, any other suggestion? Any other suggestion? Please, we are all talking. As I said, that this is going to be an interactive class, so I'm not the one going to talk. So share with us what you've gotten so far. You've spoken about science and science education. In your own way, how would you distinguish between science and science education? In your own way, as a teacher, how would you distinguish between science and science education? All right, Mr. Wusu. Mr. Wusu, you can talk. I think your hand was up. All right, I think Mr. Wusu is out. Please, I need two people to talk. Please. I'll start mentioning names. I think your names are displayed, so I'll start mentioning names. How would you distinguish between science and science education? In your own words, in your own way. All right, Madam Evelyn.
Okay, sir. So, as you said earlier, science is the pursuit of knowledge through the methods of observation and experimentation and analysis, etc. While the science education talks about how science is being taught or teaching. Thank you, sir.
All right, thank you, Sue. Okay, I think Mr. Owusu, your hand was up, right? Yes. Mr. Owusu, you can talk.
Hello, sir.
Mr. Owusu, you can talk, please.
Yes, sir. Science deals with a body of knowledge that talks about how nature works through processes, while science education deals with how scientifically we produce science literates in our various communities.
Okay. Thank you. All right, thank you all. So exactly the point. Okay. So as stated, for science, we are looking at the body of knowledge, that body of knowledge that is called science. And science education, we are looking at how we teach that body of knowledge. Okay. And so for science education, as I said, we are particularly interested in the teaching methods that we use to teach knowledge, that knowledge. We are interested in the curriculum that we are using. All right. We are interested in the strategies in a classroom, the teacher teaching. What strategies do you use to teach the science, the body of knowledge called science? What assessment methods, instrument do you use Okay, so in science education, we are looking at these things. And in science, as the body of knowledge, we are looking at just how that knowledge is acquired. So thank you very much. And then that is it. Now, let's move on to look at the characteristics of science education. The characteristics of science education. Now, as it has been stated, science education cuts across many fields in human endeavor. Okay, it's cut across. There are a lot of fields that involve science education, but science is known as the mother discipline or the mother subject, because in every field or every subject there is science in it. All right, and so once there's science in every field or every subject, there is a need for us to also learn how to teach that science. For example, when you pick social studies, sociology, there's an aspect of science in it. So it is important that the sociologist teacher is taught how to teach that science. Okay? The sociologist teacher is taught how to teach that science. So there is science in every part or every discipline or subject that we find ourselves in. All right. Now, science education is a reflective subject. That's the second point. And it is relatively sparse in content. Science education is a reflective subject, and it is relatively sparse in content. Let me take a bit of time to explain what this actually means. Now, when we say science education is a reflective subject, okay, when we say science education is a reflective subject, all that we mean is that science education examines its own practices. Okay, when we say someone is being reflective or you are reflecting on something, what happens is that you sit back and you start to think about that action that you took. And so I remember in one of the courses that we did in the university, we were taught that even as teachers, after a whole lesson, you have to be reflective. You sit back and then you start to think about how the lesson goes. And so that is basically what science education is. Science education is very reflective in nature, meaning that it examines its own practices. We think critically, okay, about how teaching happens. And out of that, we draw conclusions on how teaching is supposed to be. Okay, so it's not just, how do I put it, content that has already been prepared for us that we need to teach. No. For example, when you pick mathematics, the content in mathematics has already been given to us. If I want to teach algebra, the content of algebra has already been given to me. You understand? Has already been given to me. So I just look at what has been given to me and I teach it. But for science education, it's not like that. It is an act. It's a practice. And you can only improve that practice after you've shown it. And you sit down and you reflect on that practice. Things that went well, you maintain. Things that need to be improved, you do it. And we also do that through research. And so that is the reflective nature of science education. The content is not there. It is a practice. It is an act. And we only improve upon that practice when we become reflective of how good or bad that act goes. And so we normally say teaching is a reflective act. The same way teaching science education is also a reflective act. You have to be very reflective as a teacher. And being reflective as a teacher means that you sit down and you analyze how your teaching went. Aspect that needs to be improved, you do that. And aspect that needs to be maintained, you do that. And so that is the reflective nature of science education. We also say that it is relatively sparse in content. Now, when we say science education is relatively sparse in content, it means that it doesn't stand alone. The content in science education doesn't stand alone. Unlike the other subjects, mathematics, biology, and chemistry, which has already developed content, science education doesn't have its own content. Are you with me?
Yes, please, brother.
Yes.
sir.
So science, the
Yes, sir.
content of science education is not there. You realize that even what we're about to learn, the nature of science, you realize that everything is taken from other disciplines. We'll do a bit of philosophy, we'll do a bit of sociology, we'll do a bit of all those things. Okay, so when we say science is relatively sparse in nature, it means that science doesn't have its own content, but rather it borrows from other sources or other disciplines. Okay, that is why we say science education is relatively sparse in content. The content is not already there. What we do is that we borrow from other content. So we'll borrow a bit from psychology, where we look at the brain, how the brain functions. We'll look at psychology, teaching methods. Okay, we'll borrow a bit from sociology, where we look at equity. We'll look at all those things. We'll borrow a bit from other disciplines and put them together to form the content of science education. All right, so that's basically what we mean when we say science education is a reflective subject. Okay, and it's relatively sparse in content. Now, the other characteristics of science education is that it has no real language or rules of its own. Okay, it has no real language or rules of its own. No, they don't have that. And this also is as a result of the fact that we don't have strict content. For example, when you pick mathematics, 1 + 1 is 2. And it's a rule that you can't take away. 1 + 1 is what? It's 2. That is a rule. You can't go into other countries and tell me that 1 + 1 is 3. No. Okay. But and that is a rule, and it's a rule because mathematics has its own content. You can't change the content. But when it comes to science education, everything goes. Everything goes. And it's as a result, as I said, we don't have our own content. We borrow. So what the other things or what the other content also tells us, that is what we go by. We don't have our own content. Okay? And so that is why the third point says so. It has no real language. We don't have any real rules. We just go with the flow. All right. Okay. Is any other question? Any question that so far? Any questions so far? Is there any questions so far?
No, please.
Okay. Okay. Now, if there are no questions, then let me ask you my own questions. That's what I said. You can't just come and then listen to me and go. So let me ask my own questions. No, we are all teachers. I assume we are all teachers. Not that I assume we are all teachers. Now, what are you going to do differently? And I ask my students all these things. We are all teachers. We've passed through the education system and we know what is going on. As a science teacher, what are you going to do differently to enhance the teaching of science? We've learned about science and science education, and now we are talking about science education itself, how we teach science, and we now understand what science education is. As a science teacher who is going to practice science education, because you're going to teach science, what are you going to do differently from what the others have been doing? What are you personally going to do differently? And it's a question to the whole class. What are you going to do differently?
Hello.
Okay. I think Miss Benis, Madam Benis. Yes, I saw your hand. Okay, then Madam Evelyn, your hand is up, right?
Whatever you're saying is coming.
Okay, Madam Evelyn, you can speak, please. Madam Evelyn, you can speak. Please, did you get a question?
Read the question again.
So the question is that we are science teachers, we are ICT teachers, we are mathematics teachers. We've spoken about science education and what it is about, how we teach science. So I'm asking you, as a science teacher, we've gone through the normal education system. So what are you going to do differently to improve the teaching of science? What are you going to do differently to improve the teaching of science? Yes, Benis.
Okay, thank you for the opportunity. Please, for me, what I'm going to do differently is, think I'm going to make my lesson or the teaching of science, I'm going to introduce more of the teaching learning resources, since that is going to make the teaching of the science education more easier, understandable, and then practical in terms of the learners and then myself.
Okay.
Thank you.
All right. Thank you. All right. Okay. Madam Evelyn. Madam Evelyn can talk, please. The hand is up.
Okay, thank you, sir. So, as a science teacher, I'll make sure I learn based solely on the book that has been given to me, the textbook or the curriculum that is given to that. I'll make sure I will make extensive research on the topic that I am going to treat, and then get the teaching and learning resources that I'm going to use to make it interesting and lively. Thank you.
All right. Thank you too. One more person, then we continue, please.
Please, sir. I think for the lesson now we are just going through, then we have to get other sources. Like as you said, science is not having its own content. That means you have to search for other resources that can help us to improve our teaching and learning in classroom.
Okay. Yeah. I think that is true, and not science per se. Science has its own content. It's science education rather. All right. So
Okay,
to fully understand how to teach science well, it means you need to also consult other disciplines, as I said earlier. So there's a bit of psychology where you learn about the mind, about teaching methods. There's a bit of sociology, and the rest. You understand? So that, as you said, you have to consult other disciplines that can help you out. All right, Mr. Usu.
I think as a teacher, my main motive is how to let the people comprehend what I'm going to do. So what I'll do is involve more earlier or the teaching ready materials. Try to research. Because even if it is not there, try to watch. Get some from the people or involve the people to create some of the teaching and learning materials so that involving them will let them know what to do and understand it proper.
All right. All right. Thank you. So that is basically it. And then thank you all for your contributions. So I'm hoping that, as we say, science education is reflective. If you are going to forget anything, please don't forget this. That science education is reflective. As a teacher, you have to sit back. Mr. Osu, do you have any question? Your hand is up. Okay. Science education is reflective. As a teacher, you need to sit back and then just ask yourself what is going on, right, and what is not going well, so that as you go along, you change. That is the reflective nature of science education. So let's take to that. All right. So we can move on. Thank you all for your contributions. So that brings us to the end of section 1. We'll move on to section 2. In section 2, we are going to look at the goals and objectives of science education. We are looking at the goals and objectives of science education. That is what we are to. Hello, yeah? Anything? Hello? Okay, thank you. So we're going to look at the goals and objectives of science education. All right. Now, it is important that we look at this, because we are living in a world where there's been a lot of scientific discoveries. Almost everything that we see around us can be attributed to science. Okay. And the prosperity of the human race also depends on scientific skills. Okay. Everything around us depends on scientific skills. Even politicians depend on us, because they need the scientific resources to develop the country. Okay, and so science education offers a very important resource to man. The teaching of science, which is science education, is very important, because by so doing we are equipping the people around us to be very resourceful. And so it is very, very important. And everybody around us depends on that. That is why when we go into other countries, those developing countries, they don't joke with their science education. Go to developed countries like China, the Asia countries. I saw a video circulating, and I was marveled at how children in China are being trained. And I asked myself, when you come to Ghana, what is happening here? China, US, those developed countries, they don't joke with their science education at all, because they know how important science is to their country. And so they don't joke with it. But, okay, all comments reserved. When it comes to our part of this world, it's not like that. All right. So we need to know why science education is developed. We need to look at the goals, what science education seeks to achieve, the aims of science education. And then through that, we can appreciate that. Now, the teaching of science. Why we teach science? Why do we even teach science? Why is it important that we teach science? These are the questions we need to ask ourselves. Why do we teach science? Why is it important that we teach science? Now, these are some of the objectives or reasons why we teach science, what we teach science and we hope to achieve from. All right. 1, we teach science to help our learners develop lively, inquiring minds. We teach science to help our learners. And so the next time we go into the classroom, we should go with the mindset that we are not teaching our students to just write and pass. My dear teachers. Mr. Osu, do you have any question? Your hand is up. All right. So anytime we go to the classroom, we shouldn't teach science as in a way where we just want to teach our students to just pass. No. All right. We teach science to help our learners develop a mind of inquiry. They should be curious, and they should be willing to find reasons behind a lot of things. They should be able to do their own inquiry about a lot of things. And that is the reason why we teach science. That's one of the reasons why we do it. We teach science to help our learners develop that mind where they can do an inquiry on their own. When something is not going right, they can be able to find out why these things are not going on right. Okay, they won't just sit down not concerned and they just be like, I'm a science student. No. So the teaching of our science should reflect this. Okay? Teaching of our science should also, we teach science because we want to instill respect for moral values for other people and for oneself. Very, very important. Okay? We teach science so that people will have respect for themselves. Who have respect for themselves. When I was in SHS, there was this tag that they used to give to science students. They would say science students don't offend them. They don't engage themselves in a lot of, let me put in social vices, or they don't like problems. Like, that was the tag. Yes, they are anti-so. Thank you. They will tell you that science students are anti-so. And at a point in time, well, you would agree to that, but you see, this is not the case. In science, we are being taught how to respect one another, my brother. Okay, we should teach our students in such a way that they will respect one another. Okay, so it's not just science are anti-so, or we don't like to socialize. We just respect one another, and that is a trademark of science. And so, as a teacher, you should be able to instill that kind of attribute in your students through your teaching. If you're a biology teacher, if you're a chemistry teacher, if you are a physics teacher, an integrated science teacher, you should be able to teach science to instill this in your students. Okay, and we also teach science so that we help our students understand the world in which they live in. Okay, to help them understand the world in which they live in. Currently, you can't tell me that you see what do you call it? Rain. It rains all the time, and then you don't understand how rain is formed. No, your students should be able to tell you why rains fall. Your students should be able to tell you why the sun is shining. If there's an eclipse, your students should be able to tell you why an eclipse has occurred. If there are other things that goes on around us, your students should be able to tell you why those things are occurring. They should be able to understand the world in which you live in. So you just can't teach science like that. No. In teaching science, you should make sure that your students do understand whatever goes on around them. Okay, and we teach science to provide a basis of mathematical, scientific, and technical knowledge, enabling boys and girls to learn the essential skills necessary to change the world. Yes, I, for once, I'm a very pragmatic person. I don't believe in theories. I believe in after the theory, what next? You have to apply the knowledge that you've gotten. Okay, so we don't teach science theoretically. That was why I was asking you, what are you going to do differently? And I was surprised that no one mentioned practical applications of the knowledge. We shouldn't just teach the theoretical knowledge that are found in a book. After that, we should be able to help our students to apply that knowledge. Let me give you this practical example. Please, do you know this is a concept in physics, electricity? My physics students, electricity, right? There's this subject in electricity where you look at the plug, the electrical plug, right?
Yes.
You know that, right?
Yeah.
Yes.
Yes.
So I owe a company, a lighting company, and in one of our events, we had issues with one of our lights, and we were supposed to fix a plug. I studied this concept in SHS, and I didn't use it. I didn't see the essence of using it. But in that instance, my brother, there wasn't any electrician to help us fix the issue. So I have to take it upon myself to fix it. And you know what happened? I had to go online and check those colors of the wire. we have the life white. The life is brown, and then the neutral is blue, right? And then I think the earth is yellow, something like that.
Yes.
Though I had studied it, but I didn't know how to apply it. So I had to go online, do a lot of research before I'll be able to fix just one plug, my dear. But assuming if I had taken it seriously when I was learning it in SHS, this little thing shouldn't be an issue to us. Okay, this little thing shouldn't be an issue to us. Okay. Assuming if there was an electrician there, I would have paid the electrician to fix this simple issue for me. But these are the little things that we learned in our elementary science that we don't practice. Okay, so please, henceforth, let us not teach science as we are teaching it for teaching sake. Okay, we should teach science in a way that students will be able to apply that knowledge in their lives. All right, Madam Dennis, your hand is up.
Thank you, sir. I said I just want to share an experience.
Oh, go ahead.
As you rightly said, I think I'm also able to do some basic things in terms of this electricity. I'm able to fix the plug to fix my own ceiling fan. I think recently a colleague called that his co-tenant needed an electrician to fix his ceiling fan. So I quickly rushed to the house and then I had to do it. And I charged the woman and she paid.
Exactly. That is a good one. You see, until we accept the fact that these things that we learn in science are very practical, my dear, you wouldn't appreciate it. As I said, I'm a chemistry person. I did chemistry, but I have an event lighting company that I operate myself. I have not employed any electrician. I fix almost every electrical problem that comes my way. I didn't go to school to learn electricity or electrical engineering. I did chemistry. But in my company, I'm able to fix every electrical issue. We get it. So it is high time we approach science in a different way, my dear brothers and sisters. And we'll start with how we will teach it. Okay, it starts with how we will teach it. So we need to teach our students in such a way that after the lesson, they can apply science in their own issues. Okay, we are so much concerned about, let me teach for the student to pass. But we are neglecting the most important thing. We are neglecting the most important thing. So please, let's have a different mindset to this. Thank you very much for sharing with us. Okay, so that is what the fourth point is talking about. Now, let's move on to what science education seeks to achieve. So we've spoken about the objectives of teaching science, why we need to teach science, and what we seek to obtain from teaching science. Now, what does science education seek to achieve? So let's get the two concepts very, very well. The first one is why we teach science. Why we teach science, why teaching science is important. And for this, we are looking at what science education seeks to achieve. And the first one, we seek to achieve the promotion of teaching of science and technology linked to the society. Linked to the society. Okay? We teach science. Science education seeks to help us link science and technology to the society. I'm taking one other courses. I think the level 300s are taking one other courses called Science, Technology, and Society, where in that particular course they are being taught how science, technology, and society are linked together. So you realize that there's a direct link between science, technology, and society. And in that course, you'll be taught that don't just teach science like that. You have to teach science by linking it to your society, things around your society. So you don't teach science in an abstract. You teach it by linking it to things around your society. And so that is what science education seeks to achieve. We seek to promote the teaching of science in such a way that there will be a direct link between technology, science, and our society. Things that we study in science shouldn't be so abstract. Things that we study in science shouldn't be so abstract. We should be able to link things that we study in science to that, though everything that happens around our society. Okay, so that is what science education seeks to achieve. Two, we seek to encourage positive attitude towards science and technology. Yes, there should be an interest. There should be a growing interest and attitude towards science. Okay, when we were in school, a lot of people didn't like science because they thought science is difficult. And I don't know if it's still there.
It's still there.
It's still there.
Yes,
It's still there.
They still put science is difficult.
What's it? It's still there.
It's still there. They still put science is difficult. Mr.
Ah,
Manford.
it's still there. It's still there.
Mr. Manford, do you have anything for us?
Yes, please.
Okay, let us hear you, please.
The things I hope making science very difficult for us now is the things that we need to teach the science. That's the teaching and learning materials. We don't have them. And because of that, we do teach science just how we see, but practically we lack. So it's time they provide or we ourselves we improvise in order to do. There are some of the things that need the rare materials, and those one too we cannot buy them. So I think you the being a teacher too can also talk to other resource people so that they can also help us to buy those things. Talking of the lighting system, because we will teach and we the teachers will encourage have much more the children. No, we don't have the materials. Very difficult.
Mr. Sulu.
Good.
Mr. Sulu, don't worry. I think along the line you're going to take a course called education improvisation. Is it?
Okay.
And see, we are not. You are not being forced to teach science using those materials.
Okay.
Okay.
Yes, sir.
I don't know if anybody has any other alternative. What do you call it? Yes. View from Mr. Sulu, Mr. Manfo's view. He's saying science is difficult because there are no teaching and learning materials available. Is there any alternative view to that? Is there any alternative view to that? Yeah, Benis.
Okay, I think the first one has to do with improvisation, as he said, and then also if you are not able to improvise for the relays, then we can also take them for field trips or organization of places where they have the or resource centers. Yes, we can fund for the teaching and learning resources from the resource centers closer to our. Thank you.
Yeah, hello. I miss you so much. Yeah, so Mr. Muff, Mr. Benis, why? Please, can you change your name? It's very confusing.
Yes.
All
All
right.
right.
So
I'll do that.
The voice is
don't worry. Yes. Okay. So as Madam Benny said, you see,
Thank you.
and
For now, we can go. We can go with the name Madam Benis. I'll change it later.
all right, that's fine. So, Mr.
Thank
Mafo,
you.
see,
okay,
you see,
sir.
in our part of the world where the instruments for teaching science is not readily available, okay, I said
Okay.
that there's a course that you're going to do in level 300, that is Science, Technology, and Society, where
Oh,
in that course you'll be taught that you have to improvise. And in the improvisation, it doesn't mean you use something to represent something. No. You have to teach
okay.
science in such a way that there is a direct link to the society.
Okay.
Okay?
Yes, sir.
There are lots of things in our society that represents everything that the science textbook says.
Okay.
Okay? So
Yes.
we don't just have to assume that because there are no teaching materials, there we will have to teach science like abstractly. No, we are being encouraged that we teach science and we link it directly to our society.
Okay.
So, Mr. Amafu, I know there are things in your society that can help you teach the science. Don't just rely really on the funny saying on what do you call it? What the government is going to provide. Because if you rely on that, I'm sorry to disappoint you. It's not going to come.
Okay.
It's not going to come. So let's learn that. Okay.
Thank you, sir.
And if you even apply that, you realize that it's going to make the whole thing very, very, very what do you call it? Easy for you to actually teach. Do we get it? Yes. So, Mr. Manfo, let's look at that one too. Okay.
Okay. Thank you very much.
All right. Thank you too. All right. So that is it. So then the next point we teach the aim of science education is to increase skills in decision making, problem solving, communication, and that. Okay. And this is very important. I said that even the politicians need science education. Because when it comes to this part of our world, decision making is very poor. How politicians solve problems is very poor. And so sometimes I sit back and watch and listen to what the media is saying, and it's very funny. I just laugh. Because the analytical and the criticality of science would push people to make critical decisions. You understand? So science education seeks to achieve that. Gives people the ability to take decisions well, improve decision making, okay, and solve problem well. Let's go on. We develop more relevant curriculum in science and technology for scientific and technological literacy for all. That is what science education seeks to achieve. As I said, it's a reflective discipline. And one of the ways that we can improve that is always thinking critically about things around us, everything that goes on around us, and then trying to improve upon the things that we do. All right. So that is it. So there are a lot of what do you call it? Things in the book, that's the models in the book, points in the models that you can check it out. That would help. Now let's move on to the next concept: scientific literacy. Scientific literacy. When we say someone is a scientifically literate person, what does that mean? And this probably I'm going to be a bit controversial, but don't worry. We'll go through. When we say this person is a scientifically literate person, what does that mean? So after this, you'll be able to tell us whether you are a scientifically literate person or not, based on the explanations that we get. You should be able to tell me whether you are truly a scientifically literate person or not. So please, let's take note of that. Now, so when we say scientific literacy, we are saying is the ability to use concepts of science, scientific concepts, okay, as well as reflective, informed, ethical values in solving everyday problems and making responsible decisions in our everyday life. Let's be very careful, critical about the points. It is the ability to use scientific concepts. So it means for you to be a scientific literate person, you need to be able to use scientific concepts. So my dear brothers and sisters, the question is, are we able to use scientific concepts in our everyday life? Are we able to apply the scientific concept that we learn in our everyday life? So simply put, in order for you to be a scientific literate person, you should be able to apply scientific concepts in your everyday life. And so you should be able to explain to me why a professor in a university, a physics or an engineering professor, can't actually fix a car tire when it gets faulty, but he teaches those things in the university. So please, this is an individual question that you need to ask yourself. Please, are we or are you a scientifically literate person? Are you a scientifically literate person? You should
No.
answer that question yourself. Okay, so your ability to use scientific concepts to make decisions in your everyday life makes you a scientifically literate person. Okay. Now, there should be certain things that would also distinguish a scientifically literate person from the other people. And so that brings us to the characteristics of a scientifically literate person. When you claim that you are a scientifically literate person, what are the characteristics? What are the characteristics? And so that is what we are going to look at. One should be able to engage in responsible and personal civic actions after weighing the possible consequences of alternative options. Very, very important. Personal and civic actions. As a citizen of the country, are you able to take informed decisions? It's up to you. You should be able to defend decisions and actions using rational arguments based on evidence. Defend decisions and actions using rational arguments based on evidence. As a science student, you don't just open your mouth and talk like that. There are people, once they open their mouth, they just say whatever they have to say without evidence or without, having empirical evidence to support whatever they are saying. Please, as a scientific literate person, you should be able to have evidence to back whatever you say. You don't just say it as it is. No, that makes you a very void individual. You should be able to engage in science for excitement and explanation they provide. You should be happy doing science. I know there are a lot of, a couple of people on this call or in this class who wish they can have an alternative. Is there anyone here who would want to run away from science? Is there anyone here who would want to, if given the opportunity, will run away from science? Or we are all enjoying what we are doing?
Sir, not really.
You want to run away? Mr.
And go
Michael.
where? Sir,
Mr. Michael, you want to run away?
and go where?
Mr. Michael wants to run away. So I'm
You
asking
can't
you.
go and go anywhere.
Mr. Michael, you want to run away? Mr. Michael Jima.
Hello, sir.
Yeah, you said you want to run away.
Hello.
Mr. Michael.
It's yes, sir. It's quite 50-50 because, but well, let's hope for the best. Sometimes reading science course reading science course in Ghana is a bit quite unfortunate. Being
You can't see top,
everything you need to just adjust to it and find your way out. Mali.
Oh, Mr. Michael, that's very unfortunate.
If actually you want to run away from science, then it means you are not there to solve problems.
Is the science the only way to solve problems?
Mr. Michael, is there any other way to solve problems?
Let's cope with the lesson. Everything will be fine.
Wow.
I'm not all that scientifically inclined, but everything will be fine.
Okay, so okay. So
but it's
is it the
beautiful to learn
last?
science.
It's beautiful to learn science, right? So is it that the interest is not there, or it's just
the interest is there. The what should I even put it? One, technical know-how. You won't get science teachers around who will give you the best option to let you understand the course. Second, handout and science manual or tools and gadgets to help the learner to understand it well. It's another issue. And science itself is very bulky. So imagine you bringing all these theoretical concepts onto us for you to analyze it or help the kids to understand. Some kids want to know what do you mean by calcium, what do you mean by nitrogen and all that stuff. You, the teacher, teaching calcium, won't be that. Be just teaching them. Sometimes talking about atoms and light, magnetism, but it's interesting. Newton's first law. Oh, some science theories make sense, but no. But so let's enjoy the lesson. Let's connect. I don't want to cause any catastrophe.
Oh no. Don't worry. As I said earlier, one thing that you guys have to understand is the fact that science, as a science education, we don't have the content to Mr. Michael. Okay, so we are borrowing from all other stuff put together to present to you. Okay, and it is important that as science teachers, we get to understand the conditions on the ground. Mr. Michael. So don't worry, you are sharing with us, and whatever you are sharing is well accepted. And I know some of your colleagues also will share in your pain.
Yes, it's true.
Exactly.
You're not the only one. We are here.
You also want to leave. Madam Mercy, you also want to leave.
And the issue is that like science, it seems in Ghana here is basically theory. The practical aspect is very poor. And then the students themselves are already conditioning their mind that science is difficult. So as you are trying your possible best, it's just few who are interested. So it makes it very boring to me.
And so because of that, you want to leave?
No, it's interesting to learn science. But
it's interesting to learn science. So
yes,
don't leave.
Science is very it's a good subject, but the issue is the ground itself.
Okay, so I understand whatever. So I critically understand whatever you are saying, and in as much as it is the matter on the ground, you see, I told your colleagues last year that okay, science shouldn't be very, very difficult to teach or to study. Okay, science shouldn't be very difficult to study. Do you know the whole issue with this? You see, the standard has been set by those outside Ghana. Okay, the contents of the what do you call it, of the course that we are taking, of the science itself, has been set by those outside to suit them. And then we come to Ghana, and then it is being dumped on us that we should teach, instead of it being changed to suit our life here in Ghana or our life here in Africa. It is not done that way. So you mentioned calcium, you mentioned atoms. Those in the developed countries, they have the resources and the technology to see an atom. They have the technology to see calcium. But how can we change that concept to see it ourselves in Ghana? That is the issue. So I said earlier that we shouldn't just teach science as it is being presented to us. We should be able to teach it in such a way that we relate it to our society. Okay? We should be able to teach it in such a way that we relate it to our society. That is the best way we can teach science. So, Mr. Michael and then Madam Mercy, please don't run away. You can make a difference.
We are not running away. We are there.
Oh, you can make a difference, Mr. Michael. You can make a difference.
Yes.
I tell you.
Yes, you can do.
You can make a difference. Myself, it was my chemistry teacher in SHS who made me fall in love with chemistry. I never liked any of the sciences. I never thought I would come to the university to do chemistry and even do my master's in chemistry. No. It was my chemistry SHS chemistry teacher who made me fall in love with chemistry. And he didn't use any sophisticated instrument. We didn't even, the only element we had was sodium and those glasswares. I never saw an atom before. But the way he taught us, the way he took his time to explain details to us, made me fall in love with chemistry. Okay? So, Mr. Michael, and to all those who are encountering such an issue, you can make a difference. You don't need so much. If you're able to make use of the little that you have, you will make a difference. So please, let us run away. Where would you go if you run away? Someone asked that question. Where are you going to? There's no way to go. You go to art, you think they don't have their own issues? You don't know. All right, so that is it. So there are lots of points in that. What makes a person scientifically literate? We should value scientific research and problem solving. We should display curiosity about and appreciation for the natural human world. Okay? And this is very paramount, especially in our world where Galamsey is taking precedence there. And it's not like the scientists are not talking. The scientists are talking because they understand the nature of the effects or the nature of the problems that exactly. But the other people are not helping. Okay, so you sit back and you realize that all those people engaged in Galamsey are not scientifically literate people. Okay, you realize that all those people are not scientifically literate people, because a scientifically literate person would appreciate the natural world that we live in. But look around, they are destroying our water bodies. They are destroying our lands, cutting down trees for Galamsey. And you ask yourself, I always say that God is a very patient guy. That man up there is very patient. If it was me, let's leave it there. All right. So a scientific literate person appreciates the world and the environment the person lives in. And that person wouldn't do anything to hurt the environment. That person wouldn't do anything to hurt the environment. So if you are one of them, my dear, you're not a scientifically literate person. You are one of those people. I wouldn't want to put them in a group, but you are one of them. So please, there are a lot of points in the book. Let's just not read, but let's also reflect on what they are saying to us. Who is a scientific literate person? And based on that, we'll be able to change our lives and modify everything that we need to do. All right, please, any questions so far? Please, any questions so far? All right, so without any question, we'll move on to the third session. And in the third session, we're going to look at argument why understanding the nature of science matters. The course is nature of science. We want to know what science is, what science looks like. And so, okay. So we want to look at some arguments why understanding the nature of science matters. Why is it important that we should understand nature of science? And when we are talking about nature of science, we want to look at how science is, what science is, scientific explanations, what are they? Okay, so we need to know what people think about the nature of science. And that's basically what we're going to talk about in the third session. That's basically what we're going to talk about in the third session. Just a minute. Now, it's important. It is important that as science teachers, we understand the nature of science. It's important that we understand the nature of science. And this is because it was going to help us differentiate between what is science and what is not science. Yes, it's not everything that we need to accept as science. No. And so being able to understand the nature of science will give us the ability to differentiate between what is science and what is not science, which curriculums to develop to better teach science. Okay, so that is it. So understanding the nature of science is very, very important. It's very, very important, not to us as teachers, but also even to the society. Because as we said, the ultimate goal of education is to make people better society products for the society. The ultimate goal of what do you call it? Education is to make people better citizens or members of the society. That should be the ultimate goal. Okay. Now, in line with this, certain researchers came out with some arguments that actually helps us to understand the nature of science. We are talking about Thomas and Durant, 1987. They made certain arguments why it is important that we understand the nature of science. And as I said, this is also a bit of philosophy. So you see that in science education, we are also looking at philosophy as part of the content. We don't have our own content, as we stated earlier. And so based on Thomas and Durant's arguments, there are 5 arguments why it is important that we study science. There are 5 arguments why it is important that we study science. Now, these are the arguments. We have the economic argument, the utilitarian argument, the democratic argument, the cultural argument, and then the moral argument. According to Thomas and Durant, these are the 5 arguments why it is important that we understand the nature of science. And we're going to take time to look at them individually. Now, when they talk about the economic argument, Okay. When we talk about the economic argument, what we tend to achieve is that economically it is important, okay, that we produce qualified scientists, okay, to help maintain the industrial processes of a country. And you would understand that the industrial process or industrial process of a country actually drives its economy, drives its
Please, so what is happening? Has the lecturer left?
Hello.
Please, what is has the lecturer left?
I think so. So if we can create a WhatsApp platform from this course, I think it will help all of us. Hello.
Yes, please.
Hello.
Mr. Richmond, please do that for us. Create the WhatsApp platform for us, please.
All right, a moment. Okay, so I've posted a group link in the chats or the in-call messages section. You can join the group for natural science class. You just have to click on the link and it will just add you straight up. I'm not putting any number.
I think they block your way. Ah, me, I dey sell. You come, you block my gate. Why? Sit down. Sit. No one sit. If you don't want to, then don't stand at the gate. Sit down. This one. This one. Yes. We are going. She went to Boku. She came from Boku yesterday. If you bulk here, you don't get money. Take go Boku. You don't want to go Boku. You fear to die. What are you afraid of? You can't be Lagos boy again. Nigeria where there are bomb people. Bother here. Boku here. Mrs. Daniel.
Good afternoon, please. So
Good
sorry
afternoon,
about
sir.
that. I think there was a bit of network issues. I don't know. Yeah, so we'll have to continue. Yes, so let's continue, please. But please, before we move on, as I said, we will need an extra hour for the class. It's 3 hours, so if we do 1 hour today, we'll need extra hour so that we can make up for the few minutes that the network interrupted. So can we discuss that in the next 5 minutes, possibly, and then we choose a suitable day and time where we can all meet and then continue with the extra 1 hour.
That would be nice.
Come again?
That would be nice.
Yeah. So please, can we all decide? Please, let's all decide then.
I think somebody is helping us. Able to do that. I think it will help us.
Yeah. So can we all decide that the time that we will be available? It can be any of the days. So let's decide.
I would suggest give us the day and then the time that you will be available for us. Then we'll also take it from.
So we can do Sunday evening and then Monday evening, depending on where, or Sunday and Monday. Any of the time is okay with me. Because I know that the daytime you'll be busy, so probably should be in the evening if it's okay.
So we should pick one day out from Monday and Sunday.
Yes.
Okay. And let's pick Sunday.
Sunday, what time, please?
So we have other.
Yes.
8 to 9 p.m.
Come again?
8 to 9 p.m.
8 to 9 p.m.
Hey.
Someone said 8.
I suggest 7 to 8.
Okay. Please, the floor is open. Let's make suggestions.
Please, I think. Hello, sir.
Yes, sir.
Please, I think Sunday will be a bit of a stress for us because the whole day we are already engaged in classes.
Okay.
So I think Monday.
So Monday, right?
Will be better. Yeah.
So it's Monday, okay. So
Yeah.
Monday between 6 to 8 p.m. Wait, what do you think of that?
6 to. Hey.
It can be 6 to 7. No, wait. It can be 6 to 7 or 7 to 8. So which one do you prefer?
But then some of us, we are ladies, we have not yet finished cooking and arranging for the children to go inside. So 6 will not be favorable, please.
So 7 to. Please, let's take our time, man.
7
Let's
to
take
8.
our time. Yeah, so I gave 2 options, either from 6 to 7 or from 7 to 8. So which one will be okay for you?
7 to 8, sir.
Is our mothers, which one will be okay?
Please, 7 to 8.
7 to 8 is okay.
Please, okay. Our mothers, please, our mothers. 7 to 8.
8. Yes.
Okay.
7 to 8.
Madam Mercy.
I'm with you. It's okay.
So, hope by that time the kids will be asleep.
Yes.
Sir.
Yes, sir.
Will there be any face-to-face interaction?
No, everything is going to be online.
Okay, so throughout the same, right?
Yes, throughout the same.
Thank you very much.
For this particular course, sorry.
Okay.
For this
It seems all the courses want to do is online.
Because this morning I went to my study center. I've been there, no one was coming, so I had to make an encourage. Later on, one student told me the course is ongoing online, so I have to join.
Okay. Okay. So I think so please Monday 7 to 8 p.m. Okay, on the same course, on the same call, right?
Yes.
Okay, so thank you
But I
very
hope
much.
the slides will be sending to the platform. The slides.
Is it there's everything is in the course what do you call it? The course model. Though.
Okay.
I took everything from the course model. So I think normally when we give the slides out, students tend to depend more on that and then leave the course model. So I don't normally we don't normally share our course slide.
You're all right, sir.
Yes. See, okay, so everything is in the course model.
All right.
If you have any issue, you can just contact me and I will explain to you. But everything is in the course model.
Okay.
Okay. So please let me just use some few minutes. We have about 4 minutes. Sorry about the delay. It was a network issue. To go through model 4 and then we close, please. Just some few minutes. So we are speaking about the arguments about why understanding science, the nature of science is very important. And we spoke about 5 arguments from Thomas and Durant, who came out with 5 arguments or 5 reasons why it's important that you understand the nature of science. And these 5 arguments are the economic argument, the utilitarian argument, the democratic argument, the cultural argument, and then the moral argument. So these are the 5 arguments as to why they think understanding science education or understanding the nature of science is very important. And the first one, which is the economic argument, they believe that we need qualified scientists to help run industries in the community or in the nation. We need qualified scientists, not just anybody, but scientists who are qualified to run industries in a country. Okay, so we need to understand science to be able to produce these qualified scientists to run industries in a country and then to help promote the economic status of the country. So that is the economic argument that we need to help our country by producing qualified scientists to run industries in the country. That is where they are coming from the economic argument or the economic point of view. Now, when you pick the utilitarian argument from that side, they believe that as individuals, there are certain things or certain technologies that we encounter in our daily lives. Mobile phones, laptops, cars, washing machine, blenders, microwaves, you can name them. So they believe that you need to understand science to be able to use some of these things. You get it? So that is where the utilitarian argument is coming from. And that is personal, I believe so. So they believe that we need science to be able to manipulate and manage some of these technologies that we use in our daily lives. So that is where the utilitarians are coming from. Now, when you pick the democratic argument, or when you pick it from the democratic point of view, they believe that as citizens in the country or as citizens in the community, we are supposed to be engaged in decision making. Every decision making in the community behoves on us as individuals or part of the community to partake in that decision making. And to be able to make informed decisions, to be able to partake fully in decision makings in our country or in our society, we need a bit of science. And so that is what the democratic argument means, that we should be part of decision making. And to be able to participate fully in decision making, we need some science to be able to do that. And so there was an era where there were serious discussions on GMOs, genetically modified organisms or food. And a lot of people were saying a lot of things. It can cause cancer, it's carcinogenic, and all those stuff. But to be able to make informed decisions as to whether to accept this into our system or not, you need to know a bit of sciences. You need to know what genetically modified foods are. You need to know what goes into it and all that stuff. And so the democratic argument means that we need science to be able to make those informed decisions. For the cultural argument, they say that science is a major part of the culture of cultural argument. Every society has its own culture, its own way of life. Okay, the way the people dress, the way the people eat, the way they do their stuff, and to be able to appreciate the way of life of a particular community, you need science. You need a bit of science to be able to understand why they do certain things in order for you to appreciate it. And for them, for the moral argument, they believe that the practice of science embodies norms and commitment. Okay, the practice of science embodies norms and commitment. There are some ethical considerations around science that, as a scientist, you need to appreciate, and that would move you into the moral aspect of science. And so, these are the 5 arguments that gives us the reasons why we need to understand science and we need to even study science. And that is where the third session was talking about. And so with that, I would like to say thank you. We'll end it here. Yes, we'll end it here. I think we've done exhausted the 2 hours. We are sorry for the in between network hitches. It's normal in our part of the world. That's why we need people like you to help us. So we'll end it here. I would ask if there are any questions or if there are any concerns that we need to address. Then we call it a day.
Okay, Master, please, you made mention that if we have any concern, we can contact you, but we don't have your contact number. Please, can you help
It's
us with
it's
that?
it's on the timetable here.
Okay.
It's on the timetable. And
Okay, thank you,
it's
sir.
on the timetable.
Okay.
Yeah. So please, is there any questions that need to be addressed or any concerns?
Hello, sir.
Hey, Mr. Solomon, yeah. Okay.
Yes, please. Please, a WhatsApp platform has been created for this course. We
Okay.
don't know if we can add you to the WhatsApp group so that we can channel our issues to you through the platform.
Okay, no problem. That's fine. But please,
Okay, thank you
all
very
the
much.
issues should be pertaining this course. So I beg you.
Yes, please. Yes,
Yes.
please.
All
We will
issues
do
should be
just that.
pertaining this course. Thank you. Yes.
You're welcome.
Yes.
Okay,
Thank
then please try to share the link so that some of us you can also join that WhatsApp platform.
Yes. 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 Thank you. So we can do that. And today I think we were 35 on the course on the call. An issue happened last year where most of the students that joined us were not even up to 50. But during the last period of the course where they have to produce do presentations, we had about 100 students sending me their names. Please, let's talk to those who are not on the call. I'm taking attendance. I've taken all your names, and this call is being recorded. If you care to know, so if at the end of the period where I need to group you guys, you send me any name who hasn't been on the call, I'll be forced to take the person out and deal with only those who attend classes. And that is the university policy. Please. So tell your colleagues, please. The fact that it's online doesn't mean that it's not educating or it's not part of the class. It is also class. So please tell your colleagues.
Thank you, sir.
Okay. So I don't think there are any questions. If there are not, please. So we are meeting on Monday.
Thank you, sir.
7 p.m. to 8 p.m. Yes, on R.
Yes, sir.
All right. So please, thank you very much for your time and do have a nice day.
Thank you. Okay. Really, thank you, sir.
Thank you, sir.
Okay.
Bro, when you have to charge that.